Welcome to my channel. Your tutor Mariam is here. It's the 13th video of Introductory Physics 1 and the 9th video that I'm going to talk about the motion, which is the second subject of Introductory Physics 1. In this video, I'm going to solve the common problem which always show up in your exam or homework. If you are new to Introductory Physics 1, hit the subscribe button and like for more. You ready? Let's get started. So in this problem, let's say I'm on top of the building and I have a ball right here, right? Let's say let's call it as A. And then I'm gonna throw the ball right here. And then ball reach to the point B, right? So the first part is like find the maximum height of the ball, right? So the first things I'm gonna find is what is that h right here, right? So that's the first thing I need to solve. But let's see what I have. It says the height of the building or the height of this is gonna be 2 meters. So here I have 2 meters, right? And then the velocity here gonna be 20 meter per second, right? So the velocity for point A gonna be 20, right? So this is all I have, I think, right? But what is the meaning of maximum height? It has a meaning. As I mentioned in the previous video, a maximum height means that this is the maximum the ball can reach, right? So I suppose after reaching to a maximum, ball gonna come back to the floor, right? Or the building, right? So when it says the maximum height, that means VB gonna be 0, the velocity, because this is the maximum. So when it's reached to the maximum, the velocity gonna be 0, and then the ball gonna come back to the point it was, or it's gonna come back to the floor, right? So this is another value you have. It's like a hidden value in the problem. So I'm gonna point it here. So VB gonna be 0 at this point, right? Now let's solve the first part. So now what I have here is like VB gonna be 0, right? VA gonna be 20 meter per second, and then I know the acceleration gonna be G is gonna be 9.8 meter per second square, or I can say approximately 10 meter per second square, right? And then I also have the height of the building. I'm gonna call it as HBU, which is 2 meter, right? So now it's asked me to find the maximum height of the ball, right? There are a couple of equations you can use for this problem, right? We know the equation of motion, right? So let me write down a few of them. For example, one of them can be this equation right here. So this one can be y equal to half of g t squared plus vt plus y, right? So I have a question for you. Can I use this equation to solve this problem? Feel free to pause the video and think about it. Let's see what I have. I have y here in this equation, which I'm looking for, right? I know the acceleration, which is g. I don't know about time, right? So this one also I don't know. I know the initial velocity gonna be 20 meter per second, right? And so I know that, but I don't know about time, right? So if I'm going to use this equation, I don't know the height and also time, right? So I can't use that. I have to use the equation that time doesn't matter, right? So the equation I can use is going to be this equation right here. So this equation, which is time independent, 2g delta y, right? This is the time independent equation. Now let's solve the problem. So I know my velocity gonna be 0 because it's gonna reach to this maximum, right? And then the initial one gonna be 20 square equal to 2 times, I'm gonna say the acceleration approximately minus 10, right? And then I don't know delta y, correct? So then this gonna be minus 400 equal to minus 20 delta y, right? And then delta y equal to 20 meter, right? And this gonna be my answer for the part A. You might have this question that delta y is equal to 20, right? So what about y? We didn't calculate y. This is delta y, right? So let me explain that. Let me draw the building again. So I have this building right here, right? I have the ball right there, and then I throw it up, right? So if I take my origin here, then my y initial gonna be 0, and then I can add the height on top of this. However, I can have another choice. The other choice would be this guy right here. I have a ball here. I still am gonna throw it up, right? But I can say my origin is right here. Like if I say my y not gonna be 0 right here, right? And then I have a height of this building, and then the height of the building, this HBU, gonna be 2 meter, right? This is another choice I can have. But which one is easier for you? That's the things you should think about it. So if I go with the option 1, then what I have is like my initial gonna be on top of the building, and it's gonna be more easier to calculate. However, if I take my initial as a option 2 right here, right, then what I have is like I have to subtract or add some height, and it's going to be confusing. So in your exam, you can take the easiest origin you can and then solve the problem with that origin you want. And then you're going to come up with the same answer. It's just a time consuming, right? So what I suggest is like always go to the simplest origin you can choose. And for this problem is gonna be the point ball gonna be thrown. That's the point you should take it as an origin, right? Let's look at the second part. So it asks me what time does ball reach to the maximum height? Now this part is time dependent. I need to use the equation that time matters, right? Let's write down the equation I can use. So I'm going to use this equation. Y equal to gt square vt y. If I use this equation, then my time gonna be t square, right? Also, I have this t right here. I have all values I wanted. Like I have the acceleration, I have height, and I'm looking for t, right? So this is the right equation, right? But if I'm in the exam, I'm not gonna choose that because this one is not a linear equation and I have to spend like 3 or I don't know 5 minutes more as exaggeration. So it's like it's more time consuming to go with this equation, right? I do have another choice though, and it's this gonna be this equation. This guy right here, right? If I go with that, then I'm only dealing with the acceleration and the velocity, and this is a linear equation, right? And at least for me, it's gonna be a lot easier because I don't need to use the calculator. It takes only 1 or 2 minutes to solve, and I'm not dealing with this t square and this long equation, right? And also another point is like I don't need to use the answer from the previous part, right? If I go with that, I have to use my previous answer for y, right? So if I use that, it's like if my answer for any reason gonna be wrong, then this answer for part B also gonna be wrong because this y is wrong, right? But if I go straight with the values I have in the problem, then even if my answer for part A is wrong, still answer for part B gonna be correct, right? Hope it makes sense to you. So now let's solve the problem. So I have V, my is gonna be 0, G gonna be 10, T plus V naught, which is 20, right? And then minus 10T equal to minus 20, and then T gonna be 2 seconds, right? That's the unit. Now let's look at the last part. So here it says determine the velocity of the ball when it's returned to the height that it was thrown, right? So I'm going to draw it again to see what I'm looking for. So I have a ball here, right? I'm going to throw it up, and then it's going to come back to the same point. Let's say this is A, this is B, and then now it's going to come back to the same point. This is the velocity I'm looking for, like, so VC, correct? So I'm going to use a time independent equation, this guy right here. 2g delta y, right? So let's see what I'm going to use as an initial velocity. I'm going to use point B as an initial velocity and then come back to this point, right? So it's like my ball was here and then it's come back to the same point it was, right? So I'm going to take point B as my initial, and now I'm looking for point C, right? Now let's solve it. So it says it's reached to the maximum, right? So this VB gonna be 0, right? So it's gonna be VC squared 2 minus 10, right? And then my delta y gonna be 20. So here my answer gonna be 400 minus 400, right? So the question you might have is like, this is V squared and this is minus, right? So it doesn't make sense. If this is V squared, then this must be positive, right? So I missed something here, right? So feel free to pause the video and think about it. What should I add here to have the V as a positive? Let's go to the point I make the origin, right? So I said my origin gonna be here, right? This is the point I have the origin. So if I think about it, my origin is here, then my y-axis gonna be here, right? So this is the positive direction, correct? So now if I think about it, my ball gonna come back then the direction gonna be negative, right? Because I already suppose the direction, the positive direction gonna be upward, right? Now the ball is coming back to the point it was, right? So if this is the positive direction, this is the positive one, then this point is going to be negative because it's going to come back to the point it was, right? So what I missed here, this delta y must be negative. Let me write it down again. So this is not right, right? So this equation going to be like this. We see 2 minus 10, and this going to be minus 20, right? Which is going to be 400. Now my v is equal to positive and minus 20 meter per second, right? So now let's think about it. V can be positive or negative. Which one is right, right? Again, let's look at this origin. I have the positive direction upward, right? Now my ball reached to the point that is the negative direction, right? So my y gonna be negative and the velocity gonna be negative, right? So the right answer for v gonna be minus 20 meter per second, because my direction is downward right now. I'm hoping this example help you to understand how to solve this type of the problem with a different direction. And if you like my video, please hit the like button, and I'll see you in the next video.